So how is everyone doing? First day of build. You guys excited? That's it? You are the data people, analytics people. Are you excited? All right, that's much better. Well, good afternoon and welcome, everyone. My name is Rohan Kumar, and I'm the Corporate Vice President, Engineering of the Azure Data team at Microsoft. Thank you so much for being here with me today. You know, we have a jam-packed session of exciting announcements and demos aimed at making developers more productive and shattering the limits of what's possible with performance and scale in the cloud. How about that? Yeah. Right? OK. Now, by the end of the session, my hope is that you'll walk away with two things: how Azure delivers unprecedented performance and scale in the public cloud, and the work we are doing to make developers very productive with our databases and analytics platforms. But before we get started, I want to take a moment to thank you for your engagement and energy with our data platform. I continue to be amazed every day at the applications that are being built on Azure. You know, you're transforming industries. You're coming up with creative ways to do business, engage with your customers. The rate of progress that I've seen towards this digital transformation, by you and your peers is really, really fantastic to see. One such example of a company that's truly reinventing itself by building a set of modern applications on Azure is Paychex. Let's take a look.
Clock in, clock out. Clock in, clock out. This is how millions of hourly workers track their time, and how small and medium-sized businesses manage their people. Supporting their efforts is Paychex, a human capital management firm that pays one of every 12 private sector employees in the United States. The Paychex FlexTime app is used by millions of employees every day. It handles 13 million time cards daily, and every punch must be captured accurately, with zero downtime regardless of volume. People's livelihoods depend on it. But that volume is growing, fast. Millions of new hourly employees join the U.S. labor force every year. As Paychex experienced explosive customer growth, they reached a tipping point where their physical infrastructure became a bottleneck. They needed a solution that could keep up with the pace of their business. Something scalable, quick to deploy, cost-effective, intelligent. Paychex turned to Microsoft Azure, migrating FlexTime to Azure SQL Database, which is fully managed and has built-in intelligence to optimize performance and security, so they can serve more customers with peace of mind. Azure gives Paychex scalability they need and the reliability their customers demand, while optimizing costs and resources, freeing staff to focus on the customer. With Azure SQL Database, Paychex is creating world-class cloud apps and achieving their mission: help businesses succeed and manage their most valuable asset, people.
The challenges that were called out in the Paychex video are common across all developers. We hear this all the time. The volume of data is unpredictable, and it's growing at a very, very fast pace. To deal with these scale challenges that come up, where the volume or the size of the database grows beyond a certain point, and suddenly it negatively impacts the application or the workload performance. The developers then look for creative ways, which are typically very hard and expensive, to deal with these performance and scale challenges. And finally, it's really, really hard to make security deeply integrated and to make it just work. We believe there needs to be a better way. High-performance applications are going to become the way of the future. We already see this happening in spades. And that's the reason I'm really excited to announce the general availability of Azure SQL Database Hyperscale. Hyperscale is a cloud-native solution that we've built for relational workloads to set unprecedented benchmarks in performance and scale. When it comes to relational databases, with very high performance and scale, you typically run into challenges with resources around compute, storage, memory, or a combination of them. With Hyperscale, we've actually deeply invested in a cloud-native solution that transcends all these limitations and provides explosive performance. The best part is to gain benefits of Hyperscale, to harness its value, you don't really need to re-architect or re-implement your application. It just works. Now, the technology that we've used to build out Hyperscale is being tailor-made to all the relational databases that we have in Azure, including the open source databases. Now, let's double-click and see what exactly we did over here. At the foundation, we basically rewrote the storage engine layer and the recovery subsystem of the relational database. Effectively, you don't really need to think about pre-provisioning any of the storage requirements anymore. As your application scales and grows, the storage requirements automatically get consumed by the underlying SQL database service, right? Theoretically, there is no limit to the size of the relational database we can support with hyperscale because it's an inherently scaled out of the storage architecture. We've certified up to 100 terabytes. Things like restore times for very, very large databases are in minutes. You can independently scale up your storage and your compute layers. So for example, if you have very high read-only workload requirements, you can actually instantly create a lot of read replicas using hyperscale to offload the read workloads from your primary and significantly scale your applications. The backups are instantaneous and have almost zero impact on your I/O stack, which is phenomenal. All this value is added to the Azure SQL Database service, which already has built-in intelligence. It has built-in high availability, disaster recovery, predictable performance, rich features and security like threat detection, et cetera, and a fantastic TCO for migrating your SQL Server workloads through the Azure Hybrid benefit. To understand how this all comes together, the best way to look at the value of hyperscale is through a demo. Please let me invite Shreya Verma on stage to showcase the app. Hi, Shreya.
Hello, thank you. Hello, everyone. Today, I'm going to show you a demo of Azure SQL Database Hyperscale using a hypothetical gaming application by Wingtip Toys. Azure SQL Database has been a platform of choice for several gaming companies like Pearl Abyss. And as you all may know, that for a gaming company, high availability is critical. And the flexibility to scale up and scale down according to the workload requirements is also important. In this demo today, I'm going to show you how you can scale up and scale out a hyperscale database. So here we are looking at the operations dashboard from Wingtip Toys. And they have just launched a new game on several mobile platforms. And since the game is new, you see that the total active users, the games in progress, and the amount of transactions are fairly moderate. We see about 1,000 to 2,000 transactions here. But imagine that if this game is out there in market and it goes viral, we will see a surge in the amount of transactions happening on the database. And Wingtip Toys has provisioned the database with a 4 vCore compute, and that might not be enough to scale up to the new needs of a viral game. So here, we will go and quickly scale up the compute, and I'm going to scale it out all the way up to 80 vCores and apply. And then here, we will go back to our dashboard and see if the transactions are able to scale up accordingly. So after we scale up the compute, here we see that now the total number of active users has significantly gone up. The amount of transactions has gone up. We are able to scale up to 500,000 transactions here. And let's see now how many of these are actually reads versus writes, right? So here on this chart, you see that the amount of write transactions coming in right now is more than the amount of read transactions. And typically, when the games are out there in market for some time, as they mature, the number of writes decrease and the numbers of reads increase because the game might be out there. There are not as many user profiles being created. And now the existing users are just querying the different states in the database, right? So if we know that our database is read workload heavy, like we can see here now the reads are going up, and we see that the pattern has shifted. Hyperscale provides you a way to create readable secondary replicas. You can use readable secondary replicas to scale out your read workload or distribute your read workload. So we will go here on Azure portal and scale out our database. And I'm going to add about 3 readable secondary replicas to my database. Now, these readable secondary replicas not only provide scale out to me, but they also serve as high availability replicas. So in case my application or my primary compute was to go down due to any unforeseen circumstances, one of these replicas will become the primary and my application will not see any connectivity loss. Now, since I added readable secondary replicas, I would like my application read-only traffic to go to these read-only replicas. So what I do here is I come to connection string and I quickly change app intent to read-only. And that will take care of sending my application's read-only workload to the readable secondary replicas. So let's go back to the operations dashboard here and see if the readable secondary replicas are able to take the transactions now. And we see here that the primary replica is still serving the read and write traffic, and the 3 readable secondary replicas that I added are also now serving read-only traffic. And this way, we are able to scale out better and use the compute power from different machines and scale our workload. So today in this demo, we saw how easy it is to scale up and scale out using Azure SQL Database Hyperscale. Thank you.
Thank you. Thank you, Shreya. That is fantastic to see. You know, one of the things we hear a lot from our developers is the unpredictable and intermittent nature of a lot of their workloads, where even in the cloud today, they'll land up provisioning a lot of extra capacity to deal with peak workloads. And there's a lot of complexity that gets added to the application to manage the capacity and the infrastructure that's there, which takes their time away from actually focusing on the business logic. And that's the thing that we set out to solve about 14 months ago. Just basically solving the problem of insufficient capacity utilization, costly over-provisioning, and resources not being managed well. I mean, these workloads are actually so complex that it's really, really hard to come up with a model, a static model that essentially allows you to build, build and provision capacity. So with that, I'm really, really excited to announce the preview availability of Azure SQL Database serverless. This essentially capability gives you, or developers, the capability to focus on their workloads. They can just issue queries, and the underlying system or the service is intelligent enough to figure out the exact combination of resources, compute, memory, storage, et cetera, that are needed to essentially help the application scale and perform. And so basically, you support on-demand scaling. It's fully intelligent. The system learns based on what the workload is doing and essentially adjusts the resources. So as a developer, you basically give your min and the max size of the spend that you want, and automatically the system makes the most efficient utilization of that. And this is really, really applicable for the intermittent and unpredictable workloads. It's very cost effective because the billing constructs are actually applied on a per second basis. Right? So effectively, if you're not using any capacity or the compute essentially was shut down because your workload doesn't need it anymore or your memory requirements were adjusted, your bill starts getting improved or getting optimized on a per second basis. It's really, really great for the dev and test workloads, gaming and e-commerce, for certain kinds of workloads in these verticals from what I've seen. Really, really fantastic, and we can't wait to see what you do with it. Moving on, as we've seen a lot of new applications being built on Azure, we've definitely seen a huge uptake of the intelligent cloud, but we're also seeing a profound transformation in the application development paradigm to the intelligent edge. In fact, we believe that majority of the data in a few years will actually be stored on these edge devices. And there's a lot of locality of information that's available for you to run machine learning models, inference engines on these edge devices, right? And towards that, I'm really, really excited to announce the preview of Azure SQL Database Edge. It's the same SQL engine that you know and love that's available on premises, that's available in Azure SQL Database, now can run on edge devices. It supports the ARM architecture. Of course, it supports Linux, Windows, containers, et cetera. So all the benefits that you have with respect to query processing, security, manageability, et cetera, now have come on your edge devices. And you can imagine Azure with Azure SQL Database Edge is the only hybrid cloud that essentially provides you a very consistent programming surface across your edge devices, your private clouds, and the public cloud. Please let me invite Gregory on stage from Lenovo, who's the chief architect and distinguished engineer, to speak a little bit about how they're betting on Azure SQL Database Edge. Hi, Gregory.
Hi, Rohan. Thank you for letting me join you here today.
Absolutely.
So I actually brought you our newest server. This is an edge server called ThinkSystem BRK2013. And I'll
Wow,
let you
so this
hold it.
is a server class machine.
It's an enterprise class server, and you'll immediately notice two things about it. One, the size and weight.
It's pretty light.
And the reason that matters at the edge is it allows us to install it in a variety of applications. You can set it on a shelf, you can mount it on a DIN rail on the wall, hang it on a cabinet door, maybe even hang it on the ceiling.
Wow. It's all right. So do you want to share a little bit about the challenges that you're facing as you're building out these edge solutions?
Yeah, absolutely. So we're really focused on building compute and storage that's optimized for the edge, and this is one of our first examples here. The growth in data at the edge resulting from IoT is phenomenal, and there's huge opportunity for all of us in that. The data at the edge is challenging in terms of the ability to move it back to a central data center or a cloud because of the volume of the data, but also because of the security concerns of moving that data. The other opportunity for us at the edge is to build applications that can do real-time response. So this really means architecting applications differently so that you have compute very close to the data source.
That's really fantastic, and I agree that security could land up becoming a pretty important challenge to solve in such scenarios. So specifically, as you've looked at Azure SQL Database Edge, and we've been partnering for a while, what are the opportunities do you think it enables for our collective customers?
Yeah, I think Azure SQL Database Edge is a great match for our vision of compute and analytics at the edge. I think that it enables developers to build architectures where edge computing is integrated. And it enables you to build architectures that have both gateways and edge servers that are integrated with traditional data center or cloud computing. And so it gives us a lot of capability to work with these different types of devices, both ARM devices and x64 devices. It also has the ability to work with time series data, streaming data, and do streaming analytics at the edge, including AI, interestingly, right? There's AI built into SQL Database Edge, and that can make use of acceleration hardware that could go into an edge server. Another key aspect is management, and it's really important at the edge because there's probably no IT staff at the edge. So it's really important to think about how these solutions can be managed centrally, both the hardware and the firmware maintenance that have to happen on devices, as well as managing the application stack and the SQL infrastructure.
Perfect. Thank you so much for sharing those thoughts. It's fantastic, and I can't wait to see the scenarios that show up for both our customers.
Absolutely, and join us for our session. We have a breakout session at 3:30 if you're interested in the Sheraton room, and we'll talk more about some of the physical challenges and how we're solving them.
Well, thank you so much.
Thank you, Rohan.
It's amazing. If you look at, for those of you who've been following the innovations we've done, with the core SQL engine, we added extensibility in 2016 that supported the R language, for training and scoring against your models, and then we extended that to Python. When Greg was talking about AI built in, that capability essentially now can be run on your edge devices. And those are going to get smaller and smaller. Who would have thought a server class, enterprise class machine can just be sort of held in your hand? And the query processor working on ARM devices, you can just think about the possibilities there. So putting this in context, Azure SQL Database Edge in context with the broader edge strategy that we have in Azure, with Azure IoT, et cetera, it all seamlessly works together. To build these modern class of applications where you have hundreds and billions of devices with lots and lots of data, lots of locality where you're running these machine learning models, it takes a lot more than just physical connectivity to the cloud. Right? You need a very consistent application model, an application pattern. You need consistent security. You need consistent ways in which you look at identity. And probably the most important, consistent way in which you manage your public cloud and these massive set of edge devices that are going to get certified. And you can just imagine, when you think about smart cities or smart houses, connected factories, and all these scenarios, which effectively are powered by the intelligent cloud and the intelligent edge, the future is just phenomenal for application developers, and we are just getting started. To take a look at how Azure SQL Database Edge functions, please let me invite Saurabh on stage, who's a program manager with the Edge team. Hi, Saurabh.
Hi, thank you. So in this demo, I'll talk about how Azure Database Edge enables low latency AI streaming, data aggregation, or time windowed aggregation right on the edge, and also provides the same development experience which allows users to bring familiar tools like Azure Data Studio, Power BI, right to the edge. This demo I'm going to show is built on a manufacturing assembly line floor where you have industrial robots emitting telemetry data every few seconds. In this case, the robots are emitting data every 5 seconds. And as you can see, there are about 25 different data points or telemetry points which are being emitted by these industrial robots. This data gets streamed into a Azure SQL Database Edge engine, where the inbuilt streaming engine for SQL DB Edge can perform anomaly detection on this data and can also perform windowed aggregation of this data at a different or at a time interval. So you could do 30-second intervals, you could do 1-minute intervals, 1-hour interval, according to the requirements. So in this case, we see that the streaming engine is receiving inputs from 35 different streaming points and aggregating all of that data into multiple different output sets. These output sets are essentially SQL tables where the data is being written to. Right? So if my streaming engine identifies an anomaly in the data set, that data gets written to a SQL table for future processing. In this query, I am displaying the anomalies detected in the stream in the last 2 minutes. So there were 4 anomalies, and in each of the anomaly scenario, the engine temperature for the robot was more than 115 degrees Fahrenheit. As I was saying earlier, that streaming engine can provide capabilities to aggregate the data at a time interval. So in this scenario, I have aggregated data at a 30-second interval as the data is flowing in, and if we do not encounter an anomaly. The last part I'll talk about is the predictive analytics capability, or the built-in AI capabilities of SQL DB Edge, which allows you to run ML algorithms built in Python, R, trained in cloud, right on the edge. So in this case, I'm using the tsql predict function to run a Python algorithm which was trained using Azure ML services. And this allows me to predict or identify the root cause of the anomaly in my data set. So in this case, I see that my anomaly was because of an increase in the outside or the ambient temperature and humidity. As I was saying earlier, Azure SQL Database Edge provides the same capabilities and same tsql programming surface as Azure SQL Database, which allows us to bring familiar tools like Power BI to run analytics on that platform. So in this case, I have a Power BI desktop app which aggregates information about the anomalies in my data set at an hourly interval. So I can see at the right-hand top corner that there were 118 anomalies detected in the data stream in the last 1 hour. And in the scenario where there was no anomaly, we see that the average humidity and the average temperature is 38 and 73 respectively. But whenever there is an anomaly, my outside temperature rises to about 84 degrees Fahrenheit, and my anomaly is, the humidity is about 50, which essentially indicates that most of my anomalies are happening because of change in ambient temperature and humidity. So in this demo, we saw how Azure SQL Database Edge brings AI capabilities, streaming capabilities, time-windowed aggregation capabilities right to the edge, at the same time providing a consistent programming surface for your applications running either on edge, in premises, or in cloud. Thank you.
Thank you. Thank you, Saurabh. Wasn't that fantastic to see that level of consistency across the edge, your private clouds, and the public cloud? It's going to be pretty amazing. Moving on to open source relational databases. We made these generally available a little more than a year ago, and it's been fantastic to see the enterprise adoption of a lot of our open source databases. This is MySQL, Postgres, MariaDB. On the relational databases side, and of course, the adoption of Cassandra and Mongo on the NoSQL scaled-out multi-model side. And one of the big things we hear from our customers is the differentiation that we've sort of built in. We took the community engines. That's our commitment, where we are never going to do anything to change the surface area and create some sort of a vendor lock-in. We'll always support the community editions that are there. And underneath the covers, in the managed fabric, essentially, we build in capabilities like high availability, disaster recovery, predictable performance, security features like threat detection. A lot of the value that you actually saw in Azure SQL Database, essentially, we are bringing that to open source databases. And it's really resonating with our enterprise customers and the growth that we are seeing. It's actually fantastic to see. Now, sort of stepping back for a second, overall, if you take a look at Microsoft's commitment to open source, we've been speaking about this for several years. But just as a recap, we invested in, became a part of the MariaDB Foundation the time we announced the public preview of MariaDB. And that sort of showcases our commitment to not just leveraging the databases that are built, but actively participating and contributing back to the community. The work we are doing with Azure Data Studio to provide access to Postgres developers to actually manage their Postgres databases. At the end of the day, if you look at Microsoft's mission, we're really about empowering every person and every organization on this planet to achieve more. And a huge part of that is because of our heritage of being a tooling company. That's really, if you sort of really boil it down, that's really in our DNA. And it's so exciting to actually see when open source developers start using the tools like Azure Data Studio or the Postgres extension that we delivered with Visual Studio Code to start managing the databases. And you'll see us do a lot more in this area. The other thing I'm super excited about is, with the acquisition of Citus Data that I'll talk about in a second, we're contributing this PG Auto failover extension to the Postgres engineers. One of the things we looked at is, for us, managed services in the cloud, automatic failovers is just something that should exist in every database. And as we were building this, for providing this service for Postgres service in Azure, we felt like this was something that would be very valuable for the community. And I'm really, really excited that we're able to engage with the community in this way and contribute back the value that we are creating. So speaking about Citus, thank you, the one person who feels that as excited that I am. And that's my buddy here. I'll get to that in a second. Sort of speaking, sort of continuing to speak about the commitment that we have, we acquired Citus Data. We made this announcement back in January. And this is, again, there's lots of times when I speak to customers, they were, hey, we thought you were a SQL Server shop, what happened? And this is really our promise. Of course, we're doing great things with all our proprietary databases, whether it's Azure SQL Database, what we're trying to do with Cosmos DB, et cetera. But Azure is a platform for every developer. When you think about open source developers, et cetera, we want to be the best place in the world to run your Cassandra workloads, run your Mongo workloads, run your MySQL workloads, run your Postgres workloads, et cetera. Right? So and the Citus acquisition towards building the best Postgres service is really in tune with that strategy that we have. So with that, I'm super excited to announce the Azure Database for Postgres Hyperscale, Citus. As I mentioned a little early on, we're using the term hyperscale whenever we are sort of doing innovation inside our relational databases that breaks significantly high scale ground when it comes to performance and scale, throughput, low latency, et cetera. And with hyperscale, the work that the Citus team actually had done, leveraging that, within 4 months of acquisition, mind you, the team has worked super hard to get this value out for our customers. So how is hyperscale in Postgres, with the Citus technology differentiated? Fundamentally, using the extensibility design of Postgres, the team essentially built out an inherent scale-out compute architecture for a relational database. Now, for those of you who've been working with relational databases for a long time, you realize how challenging it is to pull off something like this. Give an illusion of a single system image to the application, and underneath the covers, based on your workload, the system actually, and the partition key that you specify, the system essentially shards the data across multiple compute nodes. So your ingestion speeds, the latency of your queries, doing operational analytics where you're ingesting the data on one side and running analytic queries on the other, all happen with fantastic performance and scale, low latency, et cetera. The other part is because it's implemented as an extension to Postgres, we always stay current with whatever is happening. It's not a fork of the Postgres code that you may have seen some of the other vendors do. Since it's built as an extension to the Postgres, the whole technology is built as an extension to Postgres, we're always going to be up to date with the latest innovation that the community is doing around Postgres. And of course, it's a managed service, so you get the simplified infrastructure to build out your multi-tenant SaaS applications and do real-time operational analytics. Again, the best way to look at the value that hyperscale Citus provides is through a demo. Please let me invite Marcus Lott on stage, who's one of the engineers with the Citus team. Hi, Marco.
Thank you. So imagine you have a very large data stream and you want to build a real-time analytics dashboard. I'm going to show you how hyperscale Citus helps you do that on Postgres, even if you have terabytes of data. As an example, I will use the GitHub data. So GitHub publishes every event that happens on a public repo via their API as a large JSON object. And there's already been terabytes of data published. So what if I want to take this large stream of data and create a dashboard that gets updated in real time, responds quickly to queries, and can support many concurrent users? If I do that on a single Postgres node, I will start reaching the limits of CPU and memory once I get to a few hundred gigabytes of data, and actually have several terabytes of GitHub data. But starting today, if I build my app using Azure Database for Postgres, I can pick the new hyperscale Citus option to scale out Postgres to as many as hundreds of nodes. So here I created a Citus cluster with 10 nodes with 32 cores each. So that's a relational database with 320 cores and 2.5 terabytes of memory. Now, to use my cluster, I can use any Postgres-compatible tool, for example, Azure Data Studio. And I created a table for my raw data, for my raw JSON data, and I called the create distributed table function added by Citus. And this is the magic trick that turns Postgres into a parallel distributed database. Now, when I copy data into this database, the data will get scattered across my 10 nodes, and I can do that in parallel. But I don't want my application to interact with these big JSON objects directly. So I also created a table called GitHub commits, where I have fields like the repo name and the author name and the message for every commit, and a table with the number of commits per day for every repository for rendering my charts in the dashboard. Now, to go from the raw data to these more structured tables, I can transform the incoming data inside my database. So I defined a function called extract commits, which inserts into the GitHub commits table and selects all the new events from the GitHub events table and also updates the summary table. Now, because these are all distributed tables, and because we're on hyperscale Citus, operations like these will actually get parallelized across all my hundreds of cores, so they can keep up with an enormous data volume. And if my data volume grows even further, I can just scale out and by adding more nodes. Now, I'm actually running these operations in the background right now. So I have around 2 terabytes of data, slightly over 2 terabytes of data across my 3 tables. And I can run queries against my database. And I'm actually re-ingesting the entire history of GitHub and then updating the dashboard in real time. So let's have a look what's going on in the background. In the top left, you see my ingestion processes writing about 1 gigabyte of data every few seconds. That's about 7 million events per minute, and each event is a 3 kilobyte JSON object. At the top right, you see the extract commits function processing the data within around 20 seconds of it being written to the database. So at that point, it's visible in the dashboard. In the bottom right, I'm actually running a benchmarking tool that is generating around 50,000 queries per second, as if there were thousands of users currently looking at my dashboard at different graphs at the same time, and they see an average of 2 millisecond response time. In addition, I can run a low latency update on a table that actually has 1 billion rows. and I can scan the table in 2 to 3 seconds. So no matter how big my data or how big my data stream, with hyperscale Citus, I can always provision enough CPU, memory, and disk to maintain high performance. And this cluster is actually probably even too big for 2 terabytes. I could probably handle tens of terabytes, but I can even scale this out to hundreds of nodes and handle hundreds of terabytes. Thank you very much.
Well, there you go. A scaled out, true scaled out relational database, and we're just getting started. So excited about what's coming in the future here. Moving on, let me invite Matthew Stokes, the Chief Product Officer of Vonto, on stage to come and share a little bit about the way they're using Citus. So tell us a little bit about the work you're driving at ASB.
Thanks, Rohan. So I'm from ASB. It's one of the largest banks in New Zealand. Along with CBA, who is our parent company, it's one of the largest banks in the world. Over the last couple of years, we've been incubating an ISV called Vonto.
So can you share a little bit about the impact that Vonto has had on the ASB customer base?
Sure. So Vonto is an analytics platform for small businesses. It takes data from underlying apps and connections and produces insights for small businesses. So let me give you an example. My local florist recently got Vonto, and she was using Facebook for her marketing. And it turns out after she put Vonto in, that actually it was better off for her to be spending that marketing money on Google AdWords. It's just one little example of how data is really empowering small businesses.
That's fantastic to hear. So tell me, as you were sort of building out these scenarios, why did you have to take a bet on hyperscale Citus, and how has that helped?
Yeah, so we had what's called a quality problem. We had a lot of customers come in a short period of time, and this really made our singular Postgres database start to creak at the seams. We found out hyperscale Citus helped us onboard customers. So we were taking about 40 minutes to onboard a customer. After 2 weeks worth of work with the hyperscale team, we got that down to 2 minutes. On top of this, hyperscale has Postgres at its heart, and that's our database of choice. And with hyperscale Citus always been on the latest version, it means we've got all the innovation and open source of the community coming across. We're really enjoying it.
Perfect. Well, thank you so much for sharing your insights, and hope you do great things with hyperscale Citus, and love your feedback to make it better.
Cheers, Ron. Really appreciate it.
Thank you. Moving on to Azure Cosmos DB, for those of you, just as a reminder, it's the only managed database service in the world that essentially supports financially backed SLAs, not just for availability. There are several services that do that, but for throughput and latency. It is the only service in the world that does. And it's really interesting, at the heart of it, if you take a look at it, with the support for multi-master, it supports 5 nines of availability, not just for your read workloads, but for your update workloads as well. And we're seeing some great traction with a lot of our enterprise customers running their mission-critical applications on Cosmos DB. The other thing that I'm really excited to announce is that in the recent Forrester Wave report covering big data and NoSQL databases, Cosmos DB was listed as one of the leaders in such a short time since its existence. And specifically for the strategy and the roadmap, it secured the highest marks. Right? And we're not surprised by this, because when we look at customers like Walmart and Symantec, and you'll see a video in a second, or Samsung, et cetera, they're all sort of leveraging, making huge bets on the mission-critical capabilities that are there with Cosmos DB. So let's take a look at how Symantec, which is one of the leaders in the security industry, is leveraging Cosmos DB to migrate their Cassandra workloads and gain significant benefit.
Our customers really trust both our experience and our knowledge and our entire security portfolio to protect them.
Throughout our journey, we've moved through many database systems, relational databases, NoSQL databases, finally landing on Azure Cosmos DB.
We managed a ton of our storage and databases within our own data centers, which was costly, slow, and really hard to predict how much infrastructure we would need. So as we've transitioned to Azure Cosmos DB, our goals are performance, reliability, and overall savings. On a daily basis, we get more than 15 billion requests, and all of those need to be handled quickly. Symantec is responsible for a lot of people's data, and the reliability of these systems has to be 5 nines, has to be up basically all the time. We've already saved 40% over what we were doing with our old database.
During our migration, one of our challenges was to move billions of records throughout many distributed databases. The Cassandra API allowed us to do a very minimalistic engineering effort. 11 lines of code were changed during that migration.
It's really easy to use. It's really fast. You can get your application running in minutes.
I trust Azure for sure. I trust Microsoft so that I can do the job that I'm responsible for, which is the security of our customers.
It's great to see, Symantec. My favorite line from that video is 11 lines of code were changed to migrate, an entire set of Cassandra workloads that they run their business on to Azure Cosmos DB. With that, one of the things that I'm super excited to talk about is the support that we are adding for Apache Spark, etc., and Jupyter Notebooks with Cosmos DB. One of the things we're hearing from a lot of our customers is they're ingesting very, very large volumes of data into Cosmos DB. And they have requirements around real-time operational analytics on that operational data that's getting stored inside the database. They don't have the freedom or the time to actually migrate that data outside into some other sort of storage system. So the key innovation that we landed with having the Spark API support is you have a scaled-out architecture in Cosmos DB, and imagine being able to intelligently run your Spark code on the compute nodes where you actually have your Cosmos DB data. It significantly helps with the latency, significantly helps with real-time applications, and which is the cornerstone of how Cosmos DB was built in the first place. For developers, the Jupyter Notebook integration is going to be phenomenal. And frankly, the best way to experience this, again, is through a demo. So please let me invite Deborah on stage. Deborah?
All right, thanks, Rohan. All right. We've increasingly heard from our Cosmos DB customers that as their workload volume scales and grows, they want to run real-time, low-latency analytics on their operational data. Let's see how Cosmos DB's new native support for Apache Spark and Jupyter Notebooks makes this all possible. Here I have my Tailwind Traders website running on Cosmos DB, and it's deployed in numerous regions all over the world. Thanks to Cosmos DB Multi-Master, users are reading and writing in every region, generating a ton of data. Now, in addition to having this core native SQL API in every region, note the new thing here is we now have Spark in every region as well. This means we can now run globally distributed Spark, AI, and analytics all on my same Cosmos DB data set. In terms of getting started, all you need to do when you create a new account is choose your API, and now select to pair Apache Spark with any of the APIs. This means that it composes well with all the data models, including key value, column family, graph, and document. Now back to my data. Here in my Data Explorer, I see two new features. We've got notebooks and Spark. In this notebook, website data, I'm going to analyze the retail purchase history data of my website. Because this notebook is directly integrated in my Azure portal and understands the context of my Cosmos account, I can immediately start querying against this account and be productive, getting the data into data frames and using all the Python data analysis libraries that we know and love. So here I have a query to calculate the total revenue by each country. And now I'm going to visualize it here using Plotly to get us a really nice world map that shows what's the distribution of revenue in each of the regions that my site is running in. I also have a query here running in the same data set to ask what are the top most popular items on my website, and create another chart here to view the conversion rate of these items as users go from viewing them to adding them to a cart to finally purchasing them. Now, in addition to notebooks, we also have the full power of Apache Spark. Here, I have a Spark cluster attached to my Cosmos DB account, and I can scale up and scale down as needed to run my compute jobs and view the operation insights. Now, the important thing to note here is that the Spark compute is co-located together with my Cosmos DB data, which means we can natively run Spark code on my Cosmos DB data without having to move any of the data at all. This means we can truly get globally distributed analytics and AI all running on my same Cosmos DB data set I already have. In this notebook here, we're going to use Spark to build a machine learning model on my purchase data. Because we have the full power of Apache Spark, we can use the entire ecosystem machine learning libraries and toolkits to help us do this. In this particular demo, we're going to build a machine learning model to predict how likely is it that someone, Rohan, will buy this Cosmos DB t-shirt on sale at our website. First, we're going to read our data from Cosmos DB, get a sense of what the data looks like, split the data into the training and test set, and then use Spark MLlib to build a logistic regression model. So very simple machine learning model here. We're going to train the model, view the predictions, and now for the moment everyone has been waiting for. What does the model predict? If we give some information along with Rohan's profile, we see that the probability of the Cosmos DB t-shirt is in fact extremely and very likely. All right. So in conclusion, with Cosmos DB's new native support for Apache Spark and Jupyter Notebooks, running globally distributed analytics on your existing Cosmos DB operational data is now easier than ever. We're so excited to see what you build with Cosmos DB. Thank you.
Thank you, Deborah. It's exciting to see all the operational analytics workloads with Spark running as a native API. Can't wait. Moving on to the analytics part, sort of the conclusive part of the demo. The first service that I'd like to cover is Azure Data Explorer. It's a fully managed serverless service that we have in Azure for real-time streaming data analytics. I mean, some of you may be aware, if you've attended some of our previous sessions, it's used by almost every engineer within Microsoft to sort of support their service operations. And we're seeing a significant growth in a lot of our enterprise customers using Azure Data Explorer. So it's fully managed. It's optimized for streaming data if you want to do things like anomaly detection, et cetera, across various client devices when they're sending the data into Azure. It's a perfect service for that. And it's really designed to be extremely simple when it comes to developer productivity. You can just get going very quickly. There is not a lot of setup that's needed. And almost every customer that I've spoken to essentially starts talking about the value that they're getting really quickly. So let's talk to one such customer who's sort of used Azure Data Explorer. Please let me invite Robert Pack, who's a research scientist at BASF. Hi, Robert.
Hi, Ryan. Thanks for having me.
So your company is one of the biggest producers of chemicals in the world. That must bring some unique challenges. Can you share a little bit?
Absolutely. So BASF operates 6 fully integrated Verbund sites across the world, along with 355 additional production sites. And at the heart of BASF strategy is what we call the Verbund strategy, which essentially means that we're not looking to optimize production within the scope of a single plant, but rather optimize production across multiple plants, across sites, across value chains. So we record data from about 20 million sensors across the world, recording things like temperature, pressure, flow rate, and exploring this very high-dimensional space and deriving actionable insights for our experts is a tremendous challenge.
I can totally imagine, especially the volumes you're talking about. So how are you using Azure?
Well, across multiple projects within BASF, we're building what I personally refer to as the data Verbund, leveraging services like Cosmos DB, Databricks, and foremost Azure Data Explorer. So based on Cosmos, we're building a graph representation of the Verbund. And this graph representation gives us the thermophysical as well as system context for all the signals we're collecting. And that allows us to automatically formulate analytics that we run inside Azure Data Explorer. Based on these analytics, we're then able to dive deeper into specific problems and provision meaningful data for training machine learning models, run these models right inside Azure Data Explorer, and quite specifically, we're now able to analyze decades of high-resolution time series data from multiple instances of a process distributed across the globe to build models not only valid for one specific plant, but for a technology as a whole. Huh?
Wow, so it's like very, very large volumes of time series data going back decades. So I know you've been working very closely with the team, so anything to share based on the experience for our audience here?
Absolutely. I mean, you did mention, so getting started with Azure Data Explorer is just, it's a fun tool to use. So that's definitely a benefit. Working with the team, with the products groups, it has been incredible fun. And when we're looking at the time series analytics that are available in there, anomaly detection, hyperlog, log, seasonality analysis comes out of the box. And that has been incredibly helpful for us. Yeah?
Well, thank you so much, Robert, for sharing your experience.
Thank you for having me. Yeah?
And it's great to have you as a customer.
Thanks.
You know, there's lots of cool new innovation that's coming with Azure Data Explorer. Like I said, it's being adopted really fast. Now there's an ability, to basically reach out into the lake. So it's not just about data stored inside Azure Data Explorer itself to do analytics and analysis on your data. So that's going to be very turnkey, and I'd love to see, get your feedback, and I'm sure the team is going to value that very much. Moving on. Now sort of getting into the modern data warehouse pipeline like we talk about. The first service I'd like to sort of talk about there is Azure SQL Data Warehouse. In my opinion, and we'll sort of get to, it's not just my opinion in a second, it is flat out the best cloud data warehouse in the world, period. I mean, you can go try out other ones, but I can tell you, you'll come back to this. Best in class price performance. We've done a tear down across all cloud data warehouses based on what our customers have asked around security, and hands down, it sort of shows up as number one. We've added intelligent workload management for you to prioritize your queries in a very cost-effective way. So if your CEO is viewing a report, viewing an operational report, you don't want that to be being interfered with some other employees, let's call it, in the company, doing the same thing. It deals with heterogeneous data, so it's not just structured, but semi-structured data in a very performant way. And all the work the team has done around developer productivity, deeply integrating it with Azure DevOps, and building that into Visual Studio and Visual Studio Code is really, really fantastic. So super, super happy about that. And by the way, like I said, this is not just what we feel. GigaOM did a completely independent benchmark testing, both focused on TPCH and TPCDS. And for those of you who are already familiar, these are the industry standard benchmarks that every CIO, if you will, should look at when they go pick their cloud data warehouse. And fundamentally, because of the innovations we've done around separation of compute and storage and intelligent caching that sort of built into SQL DW, intelligent replication of data amongst nodes to satisfy queries. The results are in front of you on the slide. So compared to Google, BigQuery, and Amazon Redshift, Azure SQL Data Warehouse clearly stands out on top, not just in terms of absolute performance, but price performance as well. And this campaign, frankly, since the time we've launched, we've gotten significant interest from our customers. So if you haven't tried it out, I highly encourage you to do that. It's just really great. Moving on, before we get to the warehouse, of course, and do all the great things around operational reports or serve real-time applications, you really need a enterprise class service to do your ETL and ELT. And Azure Data Factory essentially enables that in a pretty significant and a very, very reliable way. Today, I'm very excited to announce two new pieces of innovation that we are adding. Public preview of mapping data flows. So my friend JG sort of approached me and said, hey, look, I'd love to build out data pipelines, but I don't know how to write Spark code. And frankly, that's the thing that we hear from 80% of our developers, the data engineers who build out these pipelines, working in the enterprises. Across the board, you'll see a lot of the public clouds enable you to write, data engineers to write code, but there is nobody who natively supports a UI tool with absolutely no code that's needed. In a very declarative way, you can go to a UI tool and build out the pipeline all the way from ingestion, and these ingestion sources could be on-prem to landing your data, eventually inside the storage, warehouse, et cetera. Right? And mapping data flows essentially allows you to do that. It's a service that's available in public preview. The demand that we've seen around it is fantastic. People are loving it. If you haven't tried it again, please go try it out because it significantly reduces the friction or the pain in building out these analytics or the big data pipelines. The other thing I'm really excited to talk about is this new innovation, which is now in limited private preview called Wrangling Data Flows. So, one of the things as a data engineer, as you're building out these pipelines, when you start exploring your data sets, is the ability to wrangle the data and change the formats. We basically, with this preview, are doing that again in a no-code fashion. So the experience is actually built into the Azure Data Factory UI itself, where you can go start changing data in certain columns. And we use machine learning and artificial intelligence in the background to learn from what you did and replicate those changes across all the other data sets that are available in the column. So with mapping data flows and wrangling data flows, Azure Data Factory, hands down, we believe, is the #1 fully managed cloud service to do ETL and ELT. Just getting into the little bit of detail, I already spoke about industry-leading data ingestion. It has about 80 connectors and growing really fast. It supports hybrid environments with respecting all the security and other constraints, governance constraints that you have. It's a serverless model, so you basically pay for everything that you use. There is no managing infrastructure. Underneath the covers, the service essentially does the best possible, picks the best possible compute engine, if you will, to sort of do the work that's needed. For Azure Data Flows as an example, underneath the covers today, we use Databricks Spark, which is the best Spark that's there sort of in the world right now. But you can imagine, as more and more compute engines come up, we sort of hide those implementation details and complexity from the user so you can work in a no-code fashion. Of course, it supports managed SSIS, so if you already have your SSIS packages that you use with SQL Server, you can use Azure Data Factory to move them to the cloud. To bring it all together, please let me invite Anand on stage to showcase how modern data warehouse as a pattern gets built out and the power of Azure doing that. Thank you, Anand.
Hey, Rohan. Thank you. Hello, everyone. In this demo, I'm going to showcase how Wide World Importers, a smart retailer, is able to leverage a modern analytics solution to transform their business with data and offer omni-channel customer engagement. To do this, the retailer needs to ingest and transform data from various sources and analyze to derive business-critical insights. The goal is to improve the shopping cart size to drive revenue and sales for the organization. I'm going to use Azure Data Factory to ingest data and perform code-free transformation, use SQL DW as the serving layer for rich enterprise analytics, and Power BI as the visualization layer. Let's dive into the demo. The first step usually in such a solution is to ingest data from a wide variety of different sources to leverage the advanced analytics capabilities in Azure. I'm on Azure Data Factory, the most collaborative and a hybrid data integration service offering code-free ETL and ELT capabilities. This is the modern web-based IDE for organizations to author, manage, monitor pipelines absolutely code-free and maintenance-free using this visual experience. Here you can see the different data ingestion activities that are powering this solution. I'm able to ingest data from enterprise sources, public sources, and land that into Azure Lake so that it can be transformed, prepared for enterprise analytics. As Rohan mentioned, Azure Data Factory supports 80+ different connectors, and new connectors are getting added every month. If I want to add any new source here, I can do that with few simple clicks. Now that all this data is getting loaded into Azure, the next step is to prepare, transform, aggregate, perform data quality so that I can use this for rich enterprise analytics and power intelligent applications. As Rohan also mentioned, one of the key things we are hearing from our customers is that they need code-free visual transformation as organizations are finding it super hard to hire the right data engineers with Spark Python skill set. Now here I'm going to use the sales analytics data flow activity. This is the mapping data flow activity that we announced in public preview today. It has a bunch of different transformations that enables me to analyze, transform, perform data quality on this data visually with no code. On this particular transformation, I'm doing a join between the sales data and the customer data to identify sales trends per customer. You can see the join type here, the join condition. I can inspect the various columns used in this transformation, including the ones used in the join, and more importantly, take a quick look at the data preview for fast debug loop. If I want to add a new transformation, I can just do that from this long list of rich transformations that are supported in Dataflow. All these transformations are executing on Spark distribution, and we are supporting Azure Databricks as the first Spark distribution, and other compute will be supported over time. This is fully managed and serverless. We manage the infrastructure, run this transformation code in fully optimized manner for maximized performance and longer shelf life. Now that my data is getting transformed, the next step is to load this data into DW for rich enterprise analytics. Here I'm on Azure SQL DW, which is the most performant, secured, and best cloud-scale DW in the market today. To raise the bar, DW has recently announced support for JSON data that enables organizations to not just model and serve relational data, but also include semi-structured, unstructured data at scale. I already have my SQL DW provision, so the next step is to load this data using the DW sync in Dataflow. Dataflow uses Polybase to load the data into DW at cloud scale and also supports all these different loading patterns that you see here. Now that the data is getting loaded, if you have in the organization any Spark engineers who wants to write code, they can do that with Azure Databricks Notebook and use Azure Data Factory notebook activity to orchestrate, manage, monitor this at scale. The data flow is fully integrated with the rest of the Azure Data Factory experience, and you can use Azure Data Factory to orchestrate, manage, monitor using the same experience without context switching into anything else. The business users in the organization can use Power BI, which is connected to this modern data warehouse solution for rich reports and dashboard. It leverages the massively scalable compute capacity of the DW to serve hundreds of users parallelly. To recap, within the last few minutes, I could showcase how you can ingest data from various sources into Azure, use mapping data flow for performing code-free visual transformation, and serve rich enterprise analytics. This is just the beginning. The modern data warehouse is an extensible platform enabling organization to add additional capabilities like AI, personalization, real-time analytics, using services that natively integrates and works together seamlessly. Thank you. Over to you, Rohan.
Thank you, Anand. Well, I hope that sort of was a quick glimpse of how everything gets stitched together. If you want to sort of go modernize your enterprise data warehouse on Azure, there's a lot of effort. It's a hugely strategic area for us. And we see a lot of our customers, as they start thinking about predictive analytics, moving to the modern data warehouse pattern is really the first step towards that. And we essentially have world-class services that we are putting together. And you'll see us talk a lot more about how we are making it easier and easier to build these pipelines in the future. So with that, thank you so much. I mean, the slide sort of captures all the announcements that we had. It's really great to see all, how our customers are using the platform in Azure, both, at the edge, hybrid cloud, and the public cloud itself. So it's fantastic to see how it's coming together. There are a bunch of sessions focused around data that are there on the slide. Please go attend them and give us your feedback. Hopefully the content is going to be valuable for you. And we can't wait to see all the great new applications that you build on Azure. So have a great build, and we'll see you soon. Take care.